Hello and welcome to Echolocation Solutions.co.uk, the home of solutions of echolocation. I'm going to show you an invention that's been developed by Echolocation Solutions over a number of years. It's primarily for the blind and aims to replace the use of the eyes to provide a full 3D picture of the user's environment using sound. This is through the technique called echolocation, one that bats use to see in the dark. I'm only going to show you the simulation model since we're currently looking for funds to build a fully functional prototype. Nothing like what you'll see here has been done before and is currently patent pending at the UK Patent Office. This is a world first and this invention will give sight to the blind. So how does it work? Echolocation simply works by sending out a chirp and listening to any echoes that might return. The brain needs to understand the direction and distance of the source of the echo before it can build up a good enough picture of its surroundings. This is what this invention will do for humans, and which a bat manages so beautifully well. There is also evidence to suggest that the brain uses the visual part of the brain to process echolocation signals, which my invention taps into. Though there is still a limited number of blind people who can use echolocate, the invention will solve the major drawbacks and make it available to all blind people who are hearing abled. So onto the simulator. This is a virtual environment where any virtual model can be loaded and an echolocation signal produced that human can recognise. The models were built in Blender, and here's what this application and models look like. To keep things simple, I've created a single sphere first, and you'll be able to see this here. In my echolocation simulator, you'll see a light spot on the surface of the sphere which represents the sound reflection. There will also be a series of echolocation clicks, and you should be able to hear the sphere move up, down, left, right, in, out, and as I move the viewing angle and the position around. The up, down, left and right should be intuitive, but the distance is determined by the time delay between the first and subsequent clicks. Have a listen to the simulator and see what you think. Note that it won't work over loudspeakers, so get yourself a pair of high quality headphones. Okay, so now I'm going to move on to the next model, which is a 5-sphere simulation. You can see them here in Blender as they move around, so you should get a good sense of where things are. I'm going to move in, out, up, down, left and right and walk around it so you can see the echolocation sounds change. It might appear to be a confusing set of clicks to start with, but you should get a sense of the direction of the balls as you move around them. So that's my simulator in a nutshell. I'd love to give you some more models, but anything more complicated you wouldn't be able to recognise by someone who's not trained in echolocation. If you're interested further, there are some slideshows on the website that you can use to train yourself up with. Just go to echolocationsolutions.co.uk and go to the training material download link at the top of the page. Thanks for watching and see you next time.